In this video, we are going to learn how to solve a quadratic system of equations. Now, it involves a very similar technique that we used in the last lesson, where we need to replace y with the other equation, more or less. So we see here that y is equal to x squared plus 7x plus 12. So we can plug in that expression in for the other y in the first equation. So we can get x squared plus 7x plus 12, which replaces that y, is now equal to negative x squared minus x plus 12. And then we will proceed to move everything to one side of the equation. So we'll add x squared, giving me 2x squared. We'll add x, giving me 8x. Then we'll subtract 12, which cancels out those 12s. So we now have 2x squared plus 8x equals 0. We'll find a common factor, 2x, and we'll have 2x plus x plus 4. And our two solutions will be x is equal to 0 for the 2x, and x is equal to negative 4 for the x plus 4, which we are not done, since these are just the x coordinates of the solutions to the system. So we need to find the y. So we'll plug in 0 for x into either equation. I'll use the bottom one. So if y is equal to 0 squared plus 7 times 0 plus 12, this gives me y is equal to 12. So one solution to this system would be 0, 12. And the other solution would be when I plug in negative 4, and again, I'll use the bottom equation. So y is equal to negative 4 squared plus 7 times negative 4 plus 12, giving me 16 minus 28 plus 12. So 16 minus 28, that's going to give me negative 12 plus 12, so we get 0. So the other solution would be at negative 4, 0. Those would be the two solutions to that particular system. That's where these two graphs would meet and intersect. So let's try it out for another example. Let's see, we have here y can equal negative x squared minus 5, so I'll replace that for the y in the other equation. So we'll have negative x squared minus 5 is equal to x squared minus 4x plus 5. And again, I'll move everything to one side of the equation. In this case, I'll move to the right to keep my x squared as a positive term, giving me 0 is equal to 2x squared for the x squared plus another x squared minus 4x. And I'm adding 5, so it's not, instead of getting 0, I get plus 10. And now I will factor out a 2 to start. And I'll get 2 times x squared minus 2x plus 5. And now I'm looking for two numbers that would add to 5, that would multiply to 5, but then add to negative 2. Which at the moment I can't think of one in particular that does. So I don't think any two numbers actually multiply to positive 5 and then add to negative 2. So I'm going to have to go about solving this in a different method. If I divide by 2, I get 0 is equal to x squared minus 2x plus 5. And I can either use the quadratic formula or complete the square. And I'm going to use complete the square, so I'm going to subtract 5 from each side, giving me x squared minus 2x is equal to negative 5 when I subtract it over. And now I want to look at what I need to add to each side of the equation to complete the square. Half of negative 2 is negative 1. Negative 1 squared is 1, so we'll add 1 to each side, giving me x minus 1 squared is equal to negative 4. Which, whenever I take the square root of both sides, I'll end up getting the square root of negative 4, which is an imaginary number, 2i. The square root of negative 1 is I, the square root of 4 is 2, so I get 2i. Now to finish this off, I'll get x minus 1 is equal to plus or minus 2i. So x is equal to 1 plus or minus 2i. So my two solutions are x is equal to 1 minus 2i and x is equal to 1 plus 2i. Now, depending on the context of the problem, if I'm dealing with imaginary solutions, these wouldn't appear on the graphs of these two functions, which means that these two graphs point away from each other and don't actually intersect, but there is still a y that would also be imaginary that would go along with this x that would solve the system. So we just need to figure out what that y would be, and it's by plugging this in to the equation. So if I take x is equal to 1 minus 2i, and I plug it in to that second equation, I get y is equal to negative of 1 minus 2i squared minus 5. So when I square 1 minus 2i, I'll get 1 squared, then negative 2i for the outer, and negative 2i for the inner, so minus 4i, then plus 4i squared, minus 5. Distribute the negative, I get negative 1 plus 4i, minus 4i squared, minus 5. And then we have negative 1 minus 5, which is negative 6. Negative 4 times I squared is, if you remember, I squared is equal to negative 1. So I'll have a plus 4 with that, and plus 4i. So y would equal negative 2 plus 4i. So one solution would be 1 minus 2i, comma, negative 2 plus 4i. And I could do a very similar thing with the 1 plus 2i. And this one I'm going to go a little bit quicker through. So when I plug that in and I square it, I'll get negative 1 times 1 plus 4i plus 4i squared. That I'm going to make negative when I square it. It's a little bit of a mistake, a little blurb there, but that should be 4i squared. And you'll see here the only difference here is that negative 4i is now a positive 4i. So when I go through, I still get negative 2 because of the negative 1. And this is now going to be again, a plus 4 later on. We saw how we got here, and then a minus 5. And then we have a plus 4i for the other solution. Oh, a minus 4i, because now when I distribute, that becomes minus 4i. So now we have 1 plus 2i, comma, negative 2 minus 4i. Sorry for little blurbs going on here. But yeah. So those would be the two solutions. So depending on the context, if you're looking for a real solution, it would be no solution. But if you were allowing any solution here, we would have two imaginary points. Now, solving the next one, we'll have x squared plus 2x plus 1 plugged in for a y here. So I'll have x squared plus 2x plus 1 is equal to negative 3x squared minus x plus 2. Move everything to one side, give me 4x squared plus 3x, and then minus 1 equals 0. So now I'm looking for two numbers that would multiply to negative 4, but add to 3. So give me 4x squared plus 4x minus x minus 1, because that would be 4 and negative 1 would add to 3, but then multiply to negative 4. I'll use my grouping method. So the first group has a 4x in common. When you factor that out, you're left with x plus 1. And the second group doesn't have anything in common, but if you leave it the same, it wouldn't look like x plus 1, but we'll factor out a negative so we can get x plus 1. So we have a common factor. So fully factored, this is x plus 1 times, when you factor that out, 4x minus an understood 1. So my two solutions, when I set both factors equal to 0, would be x is equal to negative 1 and x is equal to 1/4. Now I just need to find their corresponding y values to solve the system. So I'll start with negative 1. I'll use the bottom equation. So I get negative 1 squared. I have y is equal to negative 1 squared plus 2 times negative 1 plus 1 give me y is equal to 1 minus 2 plus 1, which is 0. So one solution involving the negative 1 would be negative 1, 0. And the other solution, plug in 1/4 into, I'll just use the bottom equation as well, 1/4 squared plus 2 times 1/4 plus 1, giving me 1/16 plus 1/2 plus 1. They need a common denominator to add them all together. So I'll use 16 as the denominator. So 1/16 plus 8/16 plus 16/16. And altogether that gives me 25/16. So my other solution would be 1/4, comma 25/16 for the two solutions. Now lastly, you might come across a situation where you're seeing y squared instead of x, and the solution still comes about the same way. We'll see here we have x equal to y squared plus 4y plus 2. I can plug this in for this x, so I can get negative y squared is equal to y squared plus 4y plus 2 minus 8. So you see here I can still substitute just for the other variable. Now I'm solving for y first. So I'll add y squared so I can set it equal to 0. So I'll have 2y squared plus 4y. And here 2 minus 8 is negative 6. Now I can divide everything by 2. Give me y squared plus 2y minus 3. Two numbers that multiply to negative 3 but add to 2 would be y plus 3 and y minus 1, 3 and negative 1. So my two solutions for y would be negative 3 and positive 1. So now I just need to figure out what the y coordinates would be. So first I'll substitute in negative 3 into I'll use my bottom equation. So negative of negative 3 squared is equal to x minus 8. So that would be negative of 9 equals x minus 8. I can add 8 and get x is equal to negative 1. So one solution would be negative 1 comma negative 3. And be very mindful of which variables where, because again, it would be incorrect to say negative 3, negative 1 since we typically put x before y. And then we'll plug in y is equal to 1. Again, I'll use the bottom equation. So negative of 1 squared is equal to x minus 8. So that gives me 1 squared, which is 1. So I have negative 1 equals x minus 8. So x is equal to 7. So the other solution would be 1 comma 7. So yeah, so I showed you a variety of different situations that could show up while you're solving a quadratic system of equations. The more tricky one being when you have I involved, you'll be plugging in a binomial when checking your solutions. And that is how you solve a quadratic system of equations.